So our task in this question is to calculate the overall enthalpy change for this reaction, and then in this case they've kindly given us an equation here that we can use. They've got lots of data on the bottom, and I can see that all of this data is enthalpy change of formation, so I know this is going to be a formation cycle where we put the elements in the standard states that everything is formed from down the bottom. So let's do our first step. Our first step is to write out the balanced symbol equation for the reaction with state symbols. So in this case they've given us the equation to make it easier. That's often what they do in questions and exam questions. You rarely have to do one completely from scratch. They always give you quite a lot of the information and then you need to put it together. So here is our equation, just copied out from the top on the question. And step 2 for a formation cycle is to write out the elements in their standard states underneath, so down here, with state symbols, and make sure that that's all balanced. So if we go through the elements one by one, we've got carbon. So carbon is a solid in its standard state. Then we've got hydrogen, and hydrogen in its standard state is H2 as a gas. We've also got oxygen. Oxygen is already in its standard state over here, so it won't really contribute on this side, but over here it's combined with carbon and with hydrogen, so we will need to put the oxygen down the bottom. Also O2, also a gas. Now just to balance that so that I've got the same number of carbons and hydrogens and oxygens down here as I have up here. So 1 carbon, that's okay. 4 hydrogens, so I need 2 of these here, and 2 O2s here, so I'll need 2 O2s here. Just checking over here, I've got 1 carbon, 4 hydrogens, and 2 plus 2 oxygens, 4 oxygens down here. So that's all okay, it's all balanced. And that's the basis of our formation cycle. Then, just like we did last time, we need to do arrows, but this time we need to do arrows in the direction of the formation reactions. So that's from the elements in their standard states to the compounds. So they go up. So in formation cycles, the arrows always go up. So in formation cycles, the arrows always go up. Then we need to think about what each of these arrows represents. So over here, we're forming methane, CH4, and we're not really forming the oxygen because there's no change here. So here we're only really forming the methane. So the enthalpy change of formation of methane, and there's only one methane, so there's only one enthalpy change of formation. On this side, we're forming carbon dioxide and we're forming 2 waters. So we've got the enthalpy change of formation of carbon dioxide plus the enthalpy change of formation of water, and we've got 2 of those, 2 enthalpy change of formation of water because we're forming 2 water molecules. So we've written on the arrows the energy changes that are involved. We've taken into account the number of moles here, so we've done step 4. Step 5 is to write it out as a sum. So we're looking for this enthalpy change here, the enthalpy change of reaction here. So we're going to go down this side and up that side as our sort of cycle. So the enthalpy change of reaction going from here to here is the same as going down this way and then up that way. So remember, if you're going forwards up the arrows in the direction of the arrows, you keep the sign as it is. If you go backwards, it's minus that. So we're going backwards here, so we're doing minus the enthalpy change of formation of methane, but we're going up the arrows in the direction of the arrow on this side, so plus the enthalpy change of formation of carbon dioxide plus 2 times the enthalpy change of formation of water. And then we can just put our numbers in. So minus the enthalpy change of formation of methane, so minus 75, then plus the enthalpy change of formation of carbon dioxide, which is minus 393, and then plus 2 times the enthalpy change of formation of water, so minus 286, and then we just need to work that out. So that is plus 75, because minus 75, minus 393, because plus minus 393, and minus 572, so 2 times minus 286, which gives us minus 890 kilojoules per mole. And if you look at the reaction, because we're always worth having a check about whether that's what we'd expect, it's the combustion of methane, which you would expect to be exothermic, and it is exothermic. So that is your answer.